Hello guys, in this video I would like to explain about non-parametric correlation analysis in R and RStudio. I have done two videos in Python already about linear correlation analysis and non-parametric correlation analysis in Python, and I have given a detail about these two. In the first video I explained about linear correlation and different situation about correlation analysis, and in the second video I explain about non-parametric correlation analysis. In that case we use rank correlation analysis like Spearman-Rowe and Kendall-Tau. You can see in that video that in which situation we need to use non-parametric correlation and in which situation we can use linear correlation. So the link to those videos is given in the description of this video. So you can watch just by clicking the link and see what I have explained, because that is important for this. Why the questions come to mind that why we need this non-parametric correlation analysis. So we need to watch those videos. Then it will clear your mind that okay, why we need, in which situation I need to use non-parametric correlation analysis. You can see in this screen that this is show the quadratic, and by the way, in those videos you can see the correlation, the structure. This will something like straight, like the observation or some cluster like this. This is different. This is quadratic, and this is cubic, and this is exponential, and this is logarithmic. So there are different data sets you can have in the real life, and so it is very important to know in which situation or to which data you apply which method, because it can make difference. If you apply quadratic correlation, non-parametric correlation to the data which is linear, maybe the result is not that good. And if you apply linear correlation to the non-linear data and non-normal data, then there can be problem in the results. So this is very, very important to clear your mind that in which case you can use which correlation technique. And for this purpose you need to know the data pattern and structure of your data, which for that purpose you need to plot the data. We will do this plotting as well in this video. So let's go to the RStudio and see how we can do this stuff. Okay, so this is the script. Again, I will use the same data which I used in the previous video. In the previous video, I have done linear correlation analysis in R and RStudio. The same data from that. This is empty cars. I explain about the data in variable. So you can go and watch that video and see what and how I explain in that video. But I will just give once more question mark empty cars, the data name, by the way. Okay, so it's already come here, and then brackets, and then click. So you will see the data, the detail of the data, the package, the data, and everything. And so you can do this. I have explained this in my previous video. So just take this data and then just view first few rows of the data, that was how look like this data look like. So you can see this data look like I explained in this my previous video, so I will not explain, just watch. You select some variable from this data like MPG, HP, and WT. I explained these terms in the previous video, correlation analysis in OR, and the links to that video is given in the description, so you can go and watch that video to know what is meant by MPG, HP, and WT. So I'm choosing these variable from this empty cars data, and this will be stored in selected data. So just do this command, this will stored. Now we have three variables. You can just see SELAC. This already you can see this is here. So now you can see, and you will see that only three variables. Let's look at this. Oh no, I need to use the command head. I need to use the command. This show the total data. So now this will show you a few view. Okay, no, it should be head H. Yeah, these are the few. rows, and you can see MPG HTTP, or you choose only 3 columns from that many variables. So this is the command, and you can use another problem as well. And this will calculate the linear correlation. This is just for the comparison purpose, that if the correlation, but I think I need to calculate this later, not now. I need to plot the data first. Okay, this is already I have done, so I don't need to do these steps. Already have done, and this is already done. So I just want to make simple names. So the first variable, this variable, I assign X to this data, and HP, Y, and WTZ. So just need to do this. Now the data is in X. X has MPG, Y has HP, and Z has WT. And just plot the data, just to show the structure, or you can say the pattern, the hidden information in the data, because you cannot see this from like the data. From plot you can see, just use this, because I will use ggplot2, and this required data frames, so converting data frames, and X and Y, remember that X has MPG and Y has HPA, like this ones. Okay, remember, and W had Z had WT data weight. Now plot this data and you will see. Okay, so this look like there is no linear correlation. This look like something like this. So this is not linear correlation. And you can change the color here. You can just say COL, write this, and then whatever color you want, right? It's red. So again, run this function. You will see a different plot. Yes, red color. So you can play with these colors, these circles, and these things. So that's just to enjoy, and you can explore different colors, right? So you can see this correlation is not look like linear. It's not like this. It's little like this, something like this. So this is the correlation between X and Y, and by the way, X and Y, or MPG and horsepower and MPG. Now you can display the other variable as well. You can do more, but I will just explain X, the MPG, and weight. So just make a data frame, and then you need to use this command. And remember, you need to do the aesthetic right, otherwise there will be problem. And the color is now blue. I just mentioned it here, so you can run this command. You can see, yes, this now it look like linear some ways, but still, yes, this look like linear. As X is the MPG, and Z is the what is that? Z is weight, and yes, so this you can see. You can plot other pairs of these variable as well, as if you like. I think I should change this. Should be white Z, and it should be X MPG. I will explain this why I'm doing this. Okay, there's I need to change it here as well. C and X. Still there is problem. Oh no, it should not be capital Z, it should be small. This working now. You know what is mean by this? This is not x-axis, by the way. This is you can adjust the x-axis. This is not x-axis actually. This is just the variable name. This is y-axis, by the way. Okay, so you can change the name. This is the variable name x. You can change the name here accordingly. This is the variable name. Remember, this is not. You can write WT, not MPG. Just try if you can replace this and WT. and then see if there is no problem. Then we can do like this. Will be better. Yes, that's look. That's okay. It's good. So this is the MPG mileage per gallon and mile per gallon mileage, and this is WT weight. So you can see if the weight of the car increasing, the mileage per gallon decrease. So there is a negative correlation between these two variables. You can plot more variable as well, and you can see the pattern. So this was just a prior analysis before calculating the correlation, and you can decide about the correlation type, which correlation type you need to apply based on these plots, and to display the data. It's very important in the data science. Okay, so now we have done this. Now I need to calculate simple correlation analysis, which I have done in the previous video, but still I would like to do that. Okay, it is here. So selected data, and you can use the correlation for this selected data, 3 variables, and this will be saved in the correlation matrix. And now you can write here the correlation matrix and run it, so you will get the correlation matrix. Yes, this is the correlation, but remember this is a linear correlation. I'm using only linear here, but now I'm using Spearman correlation, which is a non-parametric rank correlation. So using this, and this data is stored, the result is stored in this, and now it is mentioned here. So just run it and you will get this is the result for Spearman rank correlation, and this is for linear correlation. Remember, we will interpret this, discuss about this. But now I'm using Kendall tau correlation. So you need to write Kendall tau, the result is stored here, Kendall underscore tau. Remember, you don't need to write like this. This creates problem. So you need to write underscore. So this is with the 2 variables. So I'm now doing this. I'm using with the 3 variable. Result will be stored in Kendall underscore tau, and the core function calculate the correlation coefficient. This is the data, and method is Kendall. Just run this and you will get this one. So now let's see the 3 correlation. The linear, the Spearman rank correlation, and the Kendall tau correlation. These 2 you can use in case of non-linear correlation and non-normal data. And of course, the third one has more advantage when you have outliers in the data. When you have few observation, you need to use Kendall tau. That's a more advantage. You can see my second video in Python about non-parametric correlation analysis. The link is given in the description, so you can see detail about this, because I have explained very detailed. Okay, now you can see, okay, this is the correlation between MPG and MPG. This is of course one which is this variable has with their correlation with their own, and this is the correlation between MPG and HP, the horsepower and the mileage. So when horsepower is increasing, mileage is decreasing. This is for sure. And this is weight. When the weight is increasing, mileage is decreasing. This has stronger correlation than the horsepower with MPG. Similarly, you can see this as now non-parametric correlation, and you can see MPG, and this is 0.89 HP. With the HP, this is stronger, very stronger than this, and this is also stronger than this. Kendall tau give different result. This is 7.4. This is less, and this is also less than this and this. So this means that you need to plot the data first, and you need to see how the data look like. If it is, as I shown some videos, if it is look like that there is no linearity, there is non-linearity in the data, and there is some outliers in the data, there is the sample is few observation, less observation, then it's better to use Spearman rank correlation, and more better to use Kendall tau test. That will give you representative results. There will be no misleading result. And if you use in this situation, use linear correlation, maybe the result will be not misleading, not representative. And if your data have these problems like non-linearity, less observation, and outliers, and then you are using linear method, which is not appropriate for this purpose, then the result may be misleading. So you need to take very good care of the data, speak with the data, plot the data, look at the data, analyze the data, and then use any of these methods. So there will be less question in your presentation, thesis, and research paper if you're using this. If you're using just blindly use a method, and there will be a lot of questions. Okay, thank you very much, and see you in the next video. Ciao.